Code here. All right, so let's let's do this for a minute. Oh, sure.
Thank you. Appreciate it.
Yeah. All right. So let's just review how we write down these limits and end behavior things and what they mean. So we'll start just going from picture to writing the limit. We'll do that one first. Okay. So each of these arrows is going to represent a limit. How do I write that one that I've highlighted in yellow? So the limit as x approaches what?
It's going. What does it mean? Is that the negative?
Well, it's going left. It's going up.
Is it negative 3?
Okay, -3, close.
Negative 3 minus?
No, they will. It's not that.
Which side of the pot -3 is it?
That's,
Yeah, the bigger values, and then we'll have the name of our function. I guess I could write that down. And then that's going to equal Aiden positive infinity. So what's this one going to be then?
X positive 1 plus 1 plus
Okay.
f of x negative 3.
Is that okay? Because I think I'll probably ask you to do this particular skill on the test. I'll give you the picture and ask you to write down the end behaviors using limits.
That one is
Negative infinity, good job, Dewan,
f of x is negative 2.
equals -2. Is this going okay? A little bit more clear what these things mean? Okay, how about this one here?
F of x positive infinity x x 1.
Yeah, that was a weird order to kind of give me the information, but
Yeah.
okay.
What came?
How about that light blue one or baby blue one? Or
Negative 3 minus f of x.
So Bloom's got it.
Yeah, I didn't have it. So that's for sure.
No, we get it.
It came back from what I saw.
Yeah, that's,
Oh, yeah.
how about this one? This last baby puke green colored one.
X equals infinity,
Good.
and then F
Yeah,
of
I
X
want
equals negative 2.
Great.
And have water all at once.
We feel okay? That help straighten out like what these limits are saying?
Yeah.
Kind of. Would have been if you paid more attention. Oh, guys. What's up?
Prior.
No, I'm curious. What's up? What was shady? When I said if you're paying more attention? Well, I was just being honest.
Who's giving out?
He gets it.
Who's giving out buck?
Caden doesn't get upset if you tell him the truth. It's like, yeah, that's you caught me.
That's what you need sometimes in life. Those are the people you keep around.
The better question is, where are the two slowest runners in the world? Where's this popcorn they ran to go get?
Oh, it's blue.
Where do you think this is?
Next is
There's
the green.
popcorn.
Yeah.
I didn't know there was popcorn.
Well, they asked if they could go get some popcorn. I'm like, they'll be like, we're really quick, we'll run. I'm like, you better run.
Yeah.
And that's like now like 4 minutes it's been.
Well, you're talking about three.
3.
To be fair.
Is she got a reputation for not being fast or just easily distractible?
Easily distracted. Easy.
Okay. Well, fair enough. All right. Should we do this last section here?
The NFL. How do we do that worksheet then? Are we gonna go over it?
Oh, you want to talk about it?
Yeah, because no.
Should we do it first?
Yeah.
Sure. We
I
can
don't know what I have to do. I'm just equal to something.
we can do that.
I'm sure it's gonna be something easy, but
You want to talk about worksheet 1 first?
yeah.
Okay. So I'm just going to be clearing fractions kind of all these, right? What I multiply both sides of this one by? I want the least common multiple of the denominators for x. So I multiply to here, that just becomes 1. Multiply to there, that just becomes x. Multiply to there becomes 2x.
But just, then I guess we're going to do
And all the denominators go away. Yeah, because 4x over 4x is just 1.
Yeah.
4x over 4 is just x. 4x over 2 is just 2x.
Okay.
And then it's piece of cake from there, right?
Yeah.
Delicious, delicious cake.
It's overthinking.
Yeah, explain that one more time.
Yeah, so I just figured out what the least common multiple of the denominators was. So between 4x, 4, and 2, just 4x, all of them will divide 4x. I distributed it through, so 4x divided by 4x is 1. 4x divided by 4 is x. And 4x divided by 2 is 2x. And then I just solved. And you just solve from there. Like, I didn't finish it, I just took it to a point where it's like, you guys definitely should know what to do from here. You know what I mean? You get to that and be like, I got it.
So for 2, then it's just B.
Yep. So that just becomes 5v minus 5. Here you got to be a little bit careful because that negative sign needs to kind of distribute through eventually. But Should be pretty easy,
Yeah.
you know, especially in the beginning. By the end, it'll get a little bit trickier because you'll have like things to factor. I only took one page of this, but the first page should be pretty straightforward. Not a whole lot of weird stuff going on. You know what I mean? Does that feel okay? Sure. Just need to see an example or something? Okay.
Not.
You're back. Where's your popcorn?
You want a piece? Oh my god.
No, thank you.
At least she actually brought. Oh, it smells really.
Yeah, you were gone for a long time.
Yeah, sorry. There was a line.
I thought I told you to run.
Did you
Go back to We cooked it for 2.5 minutes. So quiet.
All right. So, Dwan, on these first three, they all have common denominators, so there's nothing really to do. You just add the numerators and reduce if possible. So I'm going to skip those. Is that okay? Okay. So if I go down to 7, I'm just going to start by figuring out what my least common multiple of the denominators is. That would just be 4 times x minus 1. So multiply the first one by 4 over 4 and the second one by x minus 1 over x minus 1. So that gets me to here. Distribute through. And then I can try to factor and reduce that, but I don't think it factors or reduces, so they're basically done at that point. You should multiply it out and combine any like terms that you can just to get to the point where you can check to see if it is reducible, because we do need to do that. Here though, two things that multiply to give me 5 or negative 5 times 24 and add to give me 5. I don't think there's two things that do that. So I'm pretty satisfied at that point. But that's the gist of it. You know, they're just kind of all like that to some extent. The details might get a little bit more complicated, but they're all kind of the same. Is that okay? Okay. Yeah, no problem. Do you guys have any more of these that you guys want to talk about before we move on and talk about inequalities that we've put off, I think, 3 times now? That's okay. It's okay. I just want to try to get this chapter wrapped up before we have to leave on break and not leave it dangling.
Are we gonna take this test before we leave?
Yeah, that's my plan.
What day?
The full class day next week. I think there's 2 regular days and the next day next week.
Next year sounds like
That's our second. Alexis, is that our second test?
It's the second test, but I'm moving this up.
I'm good with that.
Okay. If you guys have big objections, we can talk again next class. It's not a big deal.
I'm gonna forget everything.
That's why I want to make sure we do it before we go, you know?
No, I have COVID every day. Same. And I went to my house and I'm literally like,
All right. So let's go back to like algebra 1 / pre-algebra. How do I solve an equation like this?
Like
You gotta
terms.
like
They like three
Like
together.
So minus 10 for.
X is on one side.
Yeah, you gotta get the X in the home.
But when you divide by the bottom. Yeah, flip the side.
Mhm. That's good, Caden. Yep.
That's all I remember.
Yeah, because.
And then if I were to write this using interval notation, how would I write my solution then?
Negative 1/2
Two.
to, positive infinity.
Oh, yeah.
I need some more stuff.
Jump before that, you go
That-
negative.
That's a parenthesis, and then the other one, is it a bracket for that one?
Is it a bracket or a parenthesis?
Bracket, because
It's a
that's where it
bracket
happens.
because
Because
it's.
it cannot.
No, it's a parenthesis
if it
because
has
it's
a
not
line
part of
under
the
it.
equation. If it was less than or equal to, then it'd be a bracket.
Agreed.
You lost me.
So we're talking about whether this symbol should be a bracket or parenthesis. It's a parenthesis because it's not an or equal to.
Oh, so that's a line under it?
And then if you have two, it's the union symbol.
Correct. All right. So let's now do another one. This is more of an Algebra 2 problem. I don't know if you did this or not last year because it's quadratics. I suspect maybe you did. How do I solve an inequality like this one?
Add the 4. Guys.
I would not do it that way.
All right. I'll do it that way. So you gotta do the little factor.
So I would start by pretending this is an equal zero problem.
All right. I think we
And then you could factor, or you could solve this directly by adding 4 to both sides. Please stop talking, guys. My gossip corner. Thanks. So now that I have that, if I'm interested in when x minus 4 is greater than 0, what I'm interested in then is, I know at -2 and +2, it's strictly equal to 0. Those aren't solutions, so I'm going to draw those with open circles there. And then what I'm going to do is I'm going to pick a value, any value from on those 3 places where the graph could be either positive or negative. Because I know the only place where a continuous function is going to change from positive to negative is at a x-intercept, a 0, right? So I'm just going to then plug -3 back in here. -3 squared minus 4 is 5. That's positive. 0 squared minus 4 is -4. That's negative. And if I plug 3 in, 3 squared minus 4 is 5, which is positive. So which parts am I looking for? I want greater than 0. So I want those 2 parts. So we would say that this is -infinity to -2, union 2 to positive infinity. This thing that we just did here is called a sign diagram. SIGN. What's up? I just picked some number that was less than -2 and bigger than -2 or +2. I'm just picking a value inside that interval. Can be any number. There's nothing special about -3 or 3 other than they might have been convenient to use. I mean, you could have used 15,000 instead of 3, but like, why would you use a gigantic number like that? I just picked a mental math number. You know what I mean? Yep. So I just picked something to test with. Okay. So let's do another Algebra 2 kind of example. We'll just make it a little bit more complicated. Because what you're going to see here in a minute is these guys are all going to kind of simplify down to one of these Algebra 2 kind of problems with the appropriate modifications. So same way, right? What do we start by doing? Pretend it's equal to 0. Yep. Well, I would try to factor this. Yeah, absolutely. Take an x out. Very good. And the piece that's left, you should be able to factor that, right?
Yeah. 2, -2. X minus 2.
Good. X minus 2 and x minus 2. So I have 0, 2, and 2, right? Does that feel okay? We'll draw our sign diagram. How many points do I have on here? Just 2, right? Because notice -2 is the same. So I'll just do that. Should I use an open circle or a closed circle here? Closed, very good, because it's okay if it equals 0, right? Do you guys notice that? Because it's a or equal to. So I'll pick a value for x that's less than 0, pick a value of x between 0 and 2, and pick a value of x that is bigger than 2. Now, my suggestion to you is I can do this with mental math if I think about plugging into the factored form, because here I would just have negative times negative times negative. That's negative. I don't even really care what the numbers are when I'm plugging them in, right? I'm just trying to do this like in an expedient way in my head. So if I do this one and I plug it in here, that's positive, negative, negative. That's going to be positive. And if I do the last one then, that would be positive, positive, positive. Well, that's positive. So what is my solution going to be then if I'm interested in where we're less than or equal to 0?
Negative x.
Close.
0 on the left.
And 2. Why 2? Because it's where it's equal to 0, and I care about where it's less than or equal to 0. That's sneaky, right? So how do we write that? So here's bracket. And then how do I write just 2? Well, we use the squiggly brackets, and we can just list it separately. But that's my answer. So far, so good? All right. So now on to something that is dealing with rational. So we'll do this. So we'll start the same way. We'll set this equal to 0. When is a fraction equal to 0? When the numerator is 0. Yes. Now, okay, pause for a second now, because this is an important piece. Prior to this, we were dealing with polynomials, right? Polynomials are continuous everywhere. So the only way a polynomial can change signs is at a 0. A rational function can be discontinuous. So not only can we change signs at the zeros, but also at the discontinuities, the removal discontinuities or the vertical asymptotes. So in addition to my 0, I also have to care about my vertical asymptotes and removable discontinuities. So our answers that are asymptotes or discontinuities, we always use a parenthesis because they're always undefined in the function. Here, the 0 is going to depend on whether we're talking about a less than or equal to. Since we have a greater than or equal to, we know those are going to be brackets. So I have everything I've collected all the information I need for my sign diagram. So -1, I'm going to do an open circle there. And then 4, and that's going to get a filled circle there. And then I'm just going to pick some test values. So when I plug -2 in, I get negative over negative when I plug it into here, right? So that'll be positive. When I plug 0 in, I get negative over positive. That's negative. And when I plug 5 in, I get positive over positive. That's positive. So if we want things that are greater than or equal to 0, which parts do I want? I want this piece and this piece, the positive parts. So we'd say, okay, x has to be -infinity to -1. Notice a parenthesis on the -1, union, and then I need a bracket on the 4 to positive infinity. So the hardest part about this is keeping straight whether you need a bracket or parenthesis. Because sometimes you need a parenthesis because it's a strictly less than. Sometimes you need a parenthesis because it's a result of a discontinuity, an asymptote or an RD. Is everybody okay with that? Dwan.
So going back to the previous question, can you explain why 2 is less?
Why 2 is by itself? Yeah, so if we're looking for the parts that are negative, that are less than 0, we have this piece that's negative everywhere. But at 0, or at 2, we are equal to 0, right? That was a solution. 2 is one of the solutions that are equal to 0. So I also need to include that single number 2 because it's not part of the interval that I wrote, but it still satisfies the inequality. Is that? And again, those are like the tricky ones to come up with, right? It's easy to forget those. Let's do another here. I got one more for you. So I have the square root of x plus 4 over the absolute value of x minus 1. Oy vey. All right, well, we'll do our zeros first. Notice that these are going to get parentheses, though. Why do my zeros get a parenthesis?
Because it's just straight up.
Because it's a strict greater than inequality. But I find my zeros the same way every time. I just set the numerator equal to 0. So how do I solve the square root of x plus 4 equal to 0? How do I get rid of the square root? Square both sides. Great. And what's 0 squared? Just 0. And then we'll just subtract the 4 over. So that's one thing that I need. And then my removal of discontinuities or vertical asymptotes come from when the denominator is set equal to 0. Notice here that I'm never going to really care about the reducing piece because removal discontinuities are also a discontinuity. I care about those just as much as I do the vertical asymptotes. So I'm probably always going to leave that alone. Nope. X minus, the absolute value of x minus 1 is equal to 0, the same place x minus 1 is equal to 0, right? Because all the absolute value does is makes whatever's inside positive. But 0 is already just 0, so it's fine, right? So I just add 1 over. Both of those get open circles. So I'll just pick some test values and go back and plug them in, right? We're plugging in up here. So when I plug -5 in, I get the square root of -1, which is undefined, right? That's an imaginary number. That's not something we're going to be interested in because we can't use an inequality on a complex number. So I'm just going to write undefined there. It doesn't count for either positive or negative, that section. I'll plug 0 in. Square root of 0 plus 4 is positive. And then the absolute value of something is always positive. So that's positive over positive, so positive. If I plug 2 in, x plus, or square root of x plus 2 is positive, and absolute value of anything is always going to be positive. So there's that. And since we care about greater than 0, we want this section and this section, but there needs to be a gap in there, right? At 1. So we'd write -4 to 1 union 1 to positive infinity. What do you guys think? Pretty okay. Basically, it's a solving problem plus an additional step where you just draw your sign diagram, make up your test values. But it's not too bad, right? And if you feel like you really want to plug in the test values and get the actual number, that's fine. I usually just kind of like, just because all I care about is the positive and negative, I'm just kind of doing them in my head. If you guys feel less confident in doing that stuff in your head, feel free to just type it into the calculator. So like the easiest way to do that would be to take our function, put it into the y equals menu. So I type in just like it looks on my sheet of paper. So I use the alpha y equals to get the fraction command. To get an absolute value, if you press the math button and go over to the number option, ABS is absolute value. I think there's probably an absolute value 1 or 2 in the homework. So if you wanted to do this in your calculator, it's good to know where that's at. And I'll exit out of there. I'll go vars, y-vars, function y1, just like we did in the polynomial chapter. And then I can just plug in like y1 of -5. There's my error. That's okay. That just tells me it's undefined. So just quit. Go back and I'll plug in 0 now. There's my positive. I don't care what the number actually is. I just care that it's positive or negative. And y1 of 2, that's positive. Again, I don't really care what the number is, just that it's positive or negative. That would be how I would do it if I was not confident about my mental math and was like, you know what, I'm just going to plug the numbers in. You can always do that. Again, I've been doing this job for, 20 years doing problems like this, so I'm like super confident in my mental math abilities. But if you're not there, that's okay. This is how you can use your calculator to do it quickly. That's it. That's the gist of it. So at this point, you guys should be able to finish up the problem set. So that would be 35 through 57.
You get tired, how about that? I'm just letting you know.
Change it up a bit.
How about you, man? How about you? I didn't do that.
So Thursday, when we see you guys again, we'll have the work day and the test review, and we'll talk about the test format and all that jazz. And the full-length class period day next week, we'll do the.
Next day, Monday.
I think that's what I'd heard also. That's what I had
Yeah,
heard.
it is.
We're doing Stations of the Cross that day, I think.
Oh, it's like 40 minutes.
So
Action art at our school, we just do performance in every class.